Okay. So when we're doing these problems, here's the understanding. However much chemical is in something divided by its total fluid is its percent strength. Okay, I had a real life example of when I had to do this, when the custodians had to fog last year and they had to mix whatever it is that they put inside those jugs of disinfectant. I literally did this example and to solve what they needed to put in those jugs.
You solved it for them?
Yeah.
That's so sweet. You're so nice.
So the chemical that's in there divided by the entire fluid is how strong something would be.
So it'd be 40% of a ton?
Okay, so I'm going to draw a jug. So that's my jug. Right now, it's got 20 liters. And inside of it right now, it is 40% strong. So how much antifreeze is in it? 40% of it is antifreeze. What exactly is that in liters?
I don't know.
What's 40% of 20? How do you do it in math? 20 times 0.4 is 8 liters. So that's what our jug looks like right now. Okay, what I'm going to do now is I'm going to pour more antifreeze in there. And I'm trying to figure out how much more to pour in. Okay. So what I'm going to do is I'm going to say right now, we have 8 liters of antifreeze in there already. And right now, I have 20 liters of fluid. Okay, but I'm going to add a little bit of antifreeze. I don't know how much. So what happens to the 8 liters of antifreeze? It's going to increase. I'm pouring more antifreeze in there. And what's going to happen to the 20 liters inside the entire jug? It's going to also increase. Then the result is that I want to be 60%. What are some math ways I could write 60%? 0.6. What else could I do? 6 over 10. What else could I do? 60 over 100. Okay. Any of those would work. I feel like I'm just going to pick this one because every single time I do the problem, I could just go something over 100 each time. Okay. If you want to pick the 6/10 because you reduced it, or really you could go to 3/5 or whatever, that's fine. Okay, this is the setup. So the total chemical, right, because it was 8 and we added more, the total fluid was 20, but the fluid goes up as the chemical increases. As I pour more in, your fluid is going up as well. And the result. Okay, that's it. You know how to solve this now. Yesterday, you learned how to do this. I'll give you your 2 options that you learned. Should I cross multiply or common denominator this method? Cross multiply. Because I have one fraction equal to one fraction.
Yep, exactly.
Okay, so there's my setup. This times equals this times. Okay, see what you can get for numbers. You work it through. Okay, we only have one variable, so work to get that variable alone, collect it together, isolate it.
Okay, I got it.
Okay, I got 10.
Yes.
Now, does that make sense? So if I was to add 10, I would altogether have 18 chemical liters divided by how much total fluid would I have in this jug now?
30.
30. And that equals 0.6. 60%.
No.
There it is. That's our answer. Okay, number 2. It takes Jeremy 20 minutes to push mow a yard. And if Carl helps, then it takes them 12 minutes. If Carl works alone, how long will it take him?
How long? Probably like an hour or two.
Okay, let's do a T-chart. Okay, I have time and rate, and I have Jeremy and Carl on my T-chart.
What's that first letter?
Time and rate, and Jeremy and Carl.
Cursive letters. I thought that was a star. There's so many signs in math, I just don't.
Okay, so here's the definition of rate. Let's actually probably write this down. The rate is time to complete a whole job. However long it takes you to do a whole job, that's the rate it takes you to work. Okay, so for example, let's say it takes Mrs. Falk 15 hours of work to write your report cards. Okay? Let's say I have been working a total of 5 hours. How much of my job have I completed?
1/3.
I've done 1/3 of my job. I've done 5/15 of my job. Okay? That's what we're going to go for. Okay, it takes Jeremy 20 minutes to push mow the yard. Is that considered a time that's worked or a rate to do a job? Rate. So Jeremy's rate is 20 minutes because that's how long it took him to complete an entire job. If Carl helps, then together, when they're working, it would only take 12 minutes. Is that a time or is that a rate of somebody's job? That is the time. So they both will work for 12 minutes.
Why is that there? But you can't both push mower, one push forward.
Yeah, why not? If you have two mowers?
Yeah. Well, what if you don't have two mowers? But why is that the time and not the rate?
Because the rate is for somebody to complete a whole job. And this is Carl and Jeremy working together. So it's not a rate of somebody doing a whole job. Should I add the word alone here, I guess? Would that maybe help your brain? A rate is when somebody is individual, how long it takes them to do the whole job. So this 12 minutes is a time it takes when they're both going at it. It takes them a shorter amount of time. If Carl were to work alone, how long would it take him? So that is Carl's rate. We're trying to figure out how long Carl will take alone.
Just asking the same thing, right?
No, so 12 minutes is when they were both doing it together. So now if Jeremy was to leave and Carl had to do it all alone, how long is it going to take him? Okay. So I just gave you a simple example before. If it takes me 15 hours, which is my rate to do report cards, and I've worked for 5 hours already, I'm completed 5/15 of my job. I'm a third done. Okay, so Jeremy will complete 12/20ths of the job, time over rate. Jeremy completes 12/20ths of the job. Carl will complete 12/case of the job, because I don't know. And the portion that Carl does plus the portion that Jeremy does will add up to the entire job. Just one. They do the whole job. So Jeremy will do a portion of the yard. Carl will do a fraction of the yard, right? They each do a fraction of the yard. Together they get the whole yard done.
How big is this yard?
Okay. Now, that's the new stuff. Solving this is old. How do you do it? Cross multiply or common denominator are your options. Common denominator. So that's what I look like. Okay, so what do I need to all include in my denominator? I need a 20 and a K. So 20K. Okay. Okay, we're going to we have 3 pieces here we got to look at. So look at the first one. There was a 20 and now there's a 20K. What happened to it?
K?
Multiplied by a K.
K.
So that makes 12K. Second fraction, there's a K, and now there's a 20K.
Ooh, you gotta add 20.
So I multiply by 20. That makes 240.
How? Still, why do you need it?
And how do you write 1?
Like, maybe, like, it's 20K.
20K over 20K.
Oh.
To make a 1, you need to have the same thing over the same thing, right? Now, we said our strategy was common denominator drop. So I'm solving the top equation. Do you think Carl's going to be faster or slower?
Oh, Carl is a speed monster. He cannot be slow.
Oh, he's way slower.
No way. I don't like that.
So Carl ended up being 30 minutes if he is going to do this mowing alone.
Then it should be longer.
So he's longer.
The Jeremy's like jogging.
You think that's how the world would work, but
No. Does he get paid? That's sad.
okay, you're filling up a pool. You have 3 hoses.
Why do you need 3 hoses to fill up? Is it a big thing?
Yep.
Could be a problem.
Okay. We're filling up a pool and we're going to be attaching 3 different hoses. Okay, we're also going to assume that your water pressure and all that is just consistent. Okay, this is a time and rate question. So give me the same T-chart. We have a time and a rate. And we're going to be using hose 1, 2, and 3. Okay. Remember, the definition of rate is somebody's time when they complete the job alone. That's the definition of a rate. Okay, this says, if you were to only use hose number 1, it would take 10 hours.
Wow.
Is that a time of it or a rate? A rate. 10 hours is hose 1's rate. Next, if you are to just use hose 2, it will take 12 hours.
That's a lot of time too.
That is its rate. If you were to use hose number 3, it would take 18 hours. How long does it take when you're using all 3 hoses at once?
Well, how big is this pool?
It's pretty big. If you fill a pool, it takes a big one, it takes a long time.
It really does. Like several days. Yeah.
Days, yeah.
Ours is the 15-footer, and it takes us like.
Mine is a 27-footer. It took, well, we already had our tanks full, so we were a big semi, so it doesn't take very long. We kind of cheated.
We use our little tiny garden hose.
Oh, then it would take a long
Flies
time.
out in the middle of the night, and then it's like.
Okay, ready. Time over the rate equals job done. That's our consistent strategy. The time you work over your rate is how much you've completed. So again, let's say it takes you 10 minutes to do your hair in the morning, and 3 minutes has gone by. You have completed 3/10 of the job.
On the test, are you going to give us something?
Okay, here we go. I have hose number 1. It completes x tenths of the job plus the job of hose 2, which does x twelfths of the job, plus the portion of hose 3, which does x 18ths of the job, and all 3 jobs will add up to the full job. They complete the job. Okay, so that stuff is the new part. Now, yesterday we learned, should we cross multiply or common denominator drop? Common denominator. So, whoever finds me the lowest common denominator first.
It can't be 2, can it? Because you can't go
Like, can you
There's
divide?
no way it's 2 now.
What's that?
Can you divide or something?
No, I can divide by 2.
You just need to find me the lowest common denominator. I have a candy. Whoever
Is
finds
it
it.
2,160?
No, that's a
Wait.
multiple, not a.
Ooh, it's not 36.
It can't be 2.
180?
180.
Really? I just didn't divide it. Why are you so sharp, Kelly? I'm big brain, bro. My hat barely pushed on.
180 is a number that will work for all 3 of them.
I use my head and my brain.
Okay, now, ready?
I'm ready.
One at a time. How did we turn this bottom of 10 into 180?
Multiply by 18.
I'm going to multiply by 18, turning this into 18x. How are we going to turn this bottom 12 into a bottom of 180?
15.
15. So timesing the top makes 15x. How are we turning a 180, an 18 into a 180? 10, making a 10x. How do we think of writing the number 1? The same thing over the same thing. Whatever you have, right? We now get to make the statement that we're dropping our denominator, because if the bottoms are the same, conclusion in the top is the same. I am now going to add those all up. So 43x
That does not divide nicely.
So if all of them are working together, now it will only take me 4.19 hours.
That is speedy.
I'm fast, bro.
Very cool. Our pool takes so long.
I use the neighbor's hoses. Cause like,
It's a little.
hanging with mine, I'm gonna take
Okay, number 4, and then I'll let you practice them. We need to know some physics here, physics formulas. But you can figure this out with your life. What is the speed in your car? Kilometers per hour. So, kilometers is a distance, kilometers per hour over time. See? Wasn't too hard to develop that. If you think about the speed in your car is in kilometers per hour.
Why? I really cannot.
Okay. Are you good at switching around formulas? Let's say, what is the distance? What would I do for a distance there? I would do speed times time. And how would you switch to be time in that formula?
Speed times distance. Right? Or no? Distance. Speed divided
Distance divided by speed. Okay, let's talk about some life events here. We're going to be doing a boat. And you're traveling upstream. What does the current of the water do to you when you're heading up the stream? It would be coming at you, right? When you're going up the stream, you're working against it. Same, have you guys ever biked against the wind? Okay? It comes at you, making you what? Faster or slower?
Slower. Thank you for the stuff.
Okay. What happens to you when you're going downstream or biking with the wind at your back?
You gotta just like die halfway down.
You're going to get going faster. Okay. So those are some things we need to know, understand. Something that's coming at us, slowing us down, or something pushing us from behind, right? And you can really feel that when you bike. Okay, here's the problem. A boat travels 9 miles upstream in the same time it goes 11 miles down the stream. So that's what I got out of that sentence. It's going the same time up the stream as it is going down the stream. Okay, now I'm going to use this formula, time. So distance over speed. I'm going to be using the distance over speed. All right, so we're going to now fill in what we know. A boat travels 9 miles upstream. Fill the 9 in somewhere. 9 miles upstream. We got to be on the upstream distance. In the same time, so that's why we're doing this equals thing, that it goes 11 miles down the stream. So where are you going to put 11? Distance down. The current of the river is 3 miles per hour. Find the speed of the boat. So on the bottom we have the speed of the boat. And the current of the river is 3. So one of these will have an add 3 and one will have a subtract 3. The speed of the boat.
It's a boat.
Boat. I'm just using a B for a boat.
Subtract 3 on the first one.
But I thought we need to know.
I do not know the speed of the boat. I know that the speed of the boat, when I go upstream, will be getting slowed down by 3. The boat speed will be getting slowed down by 3. When I'm going downstream, it will be the speed of my boat plus the speed of the water, making me faster. Right? Does that make sense? Okay, there's our setup. So that was the hard part. Now you can go ahead and solve it. what would you pick as a strategy? Cross multiply or common denominator drop? Cross multiply. So at the end, I got a 30-mile-per-hour boat speed when you were done working your algebra. See if you match mine. Okay, I will give you just kind of a hint when you're doing these problems. It's always going to be object speed plus minus either the current or wind speed, depending on type of question I could ask. So I might have an airplane, I might have a boat, I might have a bicycle, I might have a car. Whatever its speed is, plus or minus the speed of the wind or the water. Okay, it's always in that order. I had some people on the test that wrote it backwards, which caused them to get a negative speed on their boat. Does that answer make sense? No. I also had some people somewhere along the line, because they mixed up some order, they were getting the speed of the water to be 140 miles per hour. Does that answer make sense?
No.
No, that would be, unless we're in a tsunami or something, yeah.
Unless you're in.
Okay. So there's the strategy, but make sure your answers make sense.